Welcome. In this video I'm going to show you how you can perform a one sample proportion test using R with the stikpetR library. If you don't want to use my library, then there's a separate video on how you can also perform these tests. I'm talking plural here because it was going to use both the Wald test and the score test, the difference being whether or not you use the sample proportion or the expected proportion in the calculation of the variance. These proportion tests both are an approximation of the one sample binomial test, which I have a separate video on. This video focuses on how to get the output, not so much on if you should be using this test, and also not too much on how to interpret all the results. I'll leave a link to this Jupyter notebook in the description below, but you can also just copy the codes into RStudio, and it should run in there just the same. So to get an example, I'll use the read CSV file and the student statistics. So it's about students, and the binary field I'm going to be using is gender, because in this survey there were only males and females. Apparently there were a lot more males than females, but was this also significant? Now, using the stikpetR library, there are actually two functions in there: TS_score, TS short for test, score test, one sample, and a Wald. This library is not available on CRAN, so you will actually need to use DevTools, install, and then from my GitHub account. Once you've done that, you can simply load the library. Both the functions actually have the same parameters. The data is of course compulsory. The code, so if you have more than two categories in your data, you can select the two you want to compare. The P0 is the hypothesized proportion or the expected proportion, default set to 0.5. And if you like, you can add a Yates continuity correction. So let's take both for a spin, and as you can see, it immediately spits out the n, the statistic, the p-value, and the test, and the same for the Wald test. So the values differ slightly for these two. The n is of course the same, that's the sample size. The statistic is the z value, and the p-value is also known as the significance. In both cases, it's far below the usual threshold of 0.05, so we would then conclude that the assumption that it would have been 50-50 is rejected. And if you like, you can also add the Yates continuity correction by simply setting the CC to Yates, and then you'll notice that it actually corrects it for a bit. Alright, the other video is also about using other libraries. So for example, prop-test can do some of it, or without libraries. You can also use a chi-square goodness of fit test to approximate the normal distribution, or even a Poisson version for that. Alright, and that's all in the other video, and otherwise just look in this Jupyter notebook or on my website, and I hope this was helpful. Thank you for watching.